Continuing on with the last three problems in this section, I start out with the integral from 5 to 7 of x minus 20 dx. I'm going to use this fourth property to split that, so it's going to become the integral from 5 to 7 of x dx minus, I'm going to use the third property to pull out this 20 times the integral from 5 to 7 of dx. When I do the first one, 5 to 7x dx, that's exactly what I already have done up above. So I get 12. I'm going to subtract from that 20 times the integral from 5 to 7 of dx, which is 2. So this becomes 12 minus 40, which gives me an answer of negative 28. For part F, I'm again going to begin by splitting the integral and then pulling out the constants. So it's going to become the integral from 5 to 7 of 9 times x dx minus 1/11, the integral from 5 to 7 of x cubed dx. X dx is 12, so this is going to give me 12 times 9. I'm going to subtract from that 5 to 7 x cubed gives me 444. When I divide that by 1 over 11, 11 goes in there not evenly. I meant for it to go in evenly, so apologies, but let me do 444 divided by 11. It gives me 40.36 repeating. This we've done earlier was 108. If I do 108 minus 40.36, I get to my final answer of 67.64. For the final one, there's 3 different equations being added, so I got to split into 3 different integrals. First one is 2 times the integral from 5 to 7 of x cubed dx. Then I'm going to subtract from that 4, the integral from 5 to 7 of x dx. And I'm going to add to that 5, the integral from 5 to 7 of dx. This is going to become 2 times 444 minus 4 times 12 plus 5 times 2. If I put all that into my calculator, 2 times 444 minus 4 times 12 plus 5 times 2, that gets me to my final answer of 850.